Right, good day, grade 11 mathematics learners, and welcome to our session number 2 for our June paper 1 examination revision. Right, today we're going to look in this session at number patterns, and we start here with question 3. 3.1, given the finite linear patterns, now it's linear, so it has a constant difference, and we know that Tn is equal to Bn plus C. 12, 17, 22, etc. And then the last term there is 172. 3.1.1. Determine a formula for the nth term of the pattern 2 marks. So that's the general term, that's Tn. Well, we know Tn is equal to Bn plus the C, since it is a linear pattern. So we need to find the B and the C. Well, if you are at the 12, what must you do to get to the 17? Add 5. If you are at the 17, what must you do to get to the 22? Add 5. So our constant difference is 5. So now we know Tn is equal to 5n and then plus or minus something. Now if I substitute a 1 in there, it's 5 times 1. If I substitute a 1 in for n, and it's 5 times 1, that is 5. But the question is, what must I do to get to the 12 still? We need to add 7. So now we know that Tn is equal to 5n plus 7. You're going to get a mark there for the 5n, and you're going to mark there for your 7. And then 3.1.2, calculate the value of T12, 2 marks. So we have its position. It's in the 12th position of our linear pattern, but we don't know its value. Remember that the 12 here is the n. So again, we can say T12 equals 5 times 12 plus n. We merely substituted 12 in the position of n there. And 5 times 12 plus the 7 is 67. So the value of the 12th term is 67. So you get a mark there for that substitution, and you get a mark there for your answer. 3.1.3, determine the number of terms in the pattern, 2 marks. Again, you can use your general term formula to determine how many terms there are. Well, then you must look at the last one. We know the value of the last term is 172, but we don't know its position. So if I can find its position, then I know how many terms there are in total. So 5n plus 7 equals 172. Remember, you want to find the value for n now. That's the position. So you subtract 7 from both sides. 5n equals 165. And you divide both by 5, you get n is equal to 33. So you get a mark there for equating your 172 to your 5n plus 7. And you get a mark there for n equals 33. And then 3.2, given the first 4 terms of a linear pattern, 3, x, y, and then 30, calculate the values of x and y, 4 marks. Right, so T1 is 3, T2 is x, T3 is y, and T4 is 30. Remember, it's linear, so it has a constant difference. If you want to work out the constant difference, you can say T2 minus the T1, so that's x minus 3 here. T3 minus the T2, that's y minus x. And 30 minus the y, that's 30 minus y here. And they are all equal since it's a linear pattern, so there's a constant difference. So if you look at these two here, you can equate them. X minus 3 equals y minus x. So if you solve for y there, you'll get y equals to 2x minus 3. Right, so we can also look at this one here. We can equate the x minus 3 with the 30 minus y. So x minus 3 is equal to 30 minus the y. X minus 3 equals 30 minus the 2x plus the 3. So remember, instead of the y, I can just substitute in that 2x minus the 3 in there. Right, then you'll get minus 2x plus 3. So if you get the x's to one side and the numbers to the other side, 3x will equal to 36. So x is equal to 12. You can take this x equals to 12, sub it back in here for x for that first one. Y equals 2 times 12 minus 3, and you'll get y is equal to 21. So you get a mark there for x minus 3 equals y minus x, this one. You also get a mark there for 30 minus y equals y minus x, or for this one here, x minus 3 equals 30 minus y. For equating them and then solving for x equals 12 and for y is equal to 21. Right, here's our next question. Question 4. Given the quadratic pattern 244, 193, 148, 109, etc. 4.1. Write down the next term of the pattern 2 marks. It's quadratic, so it has a first difference and it has a constant second difference. If you look at T1, it's 244, T2 is 193. What must we do to get from 244 to 193? We say minus 51. If we are at 193, what must we do to get to 148? Well, we must say minus 45. If we are at 148, what must we do to get to the 109? Well, we must say minus 39. So this line here is the first difference, and notice that's not constant. But the second difference of a quadratic pattern is constant. If we are at the negative 51, what must we do to get to the negative 45 plus 6? This is the second difference now. If we are at the negative 45, what must we do to get to the negative 39 plus 6? So if you want the next one here, you will need to add 6 to that one as well. So negative 39 plus the 6 will be then a negative 33. And so 109 minus the 33 will give us our T5, which is 76 then. So you get a mark there for calculating the first and the second differences. And you get a mark there for your answer for T5 equals 76. Right, now for 4.2. Determine a formula for the nth term of the pattern 4 marks. So we know Tn is equal to an squared plus bn plus c. So we must find a, b, and c. Well, we know you must equate the 2a to that second difference. So we say here 2a is equal to 6. A is then equal to 3. Divide both sides by 2. So a is equal to 3. And we also know that 3a plus b is equal to that first term's value of our first differences. That's negative 51. So we say 3a plus b equals negative 51. We've just solved for a equals 3, so we can substitute that in for a. So 3 times 3 plus b equals negative 51. That'll be 9 plus b equals negative 51. Subtract 9 from both sides, b is equal to negative 60. And now we also remember that then the value of this first term, a plus b plus c, will be equal to that 244. So we say a plus b plus c equals 244. We have a as 3, we have b as negative 60, and then plus c equals 22, 244. If you solve for c there, you'll get c is equal to 301. So Tn is equal to 3n squared minus 60n plus 301. And then for 4.2, determine a formula, 4.3, which term of the pattern will have a value of 508 marks. So we equate our general term that we got from 4.2 to the value of 508. We want the position, which term? So we want n. So we say 3n squared minus 60n plus 301 equals 508. Remember, you need to take the 508 to the other side. Then you get 3n squared minus 60n minus 207 equals 0. That's standard form. You can factor out the 3 of each term there. Then you'll have n squared minus 20n minus 69 equals 0. That you can factorize into two brackets. N plus 3 times n minus 23 equals 0. So n equals 23 or n equals negative 3. We don't have a term position of n equals negative 3. So we must take the n equals 23. You get a mark there for equating the 508 to our Tn. You get a mark for the standard form here where we say it's equal to 0. You get a mark there for factorizing, and you get a mark there for stating n equals 23. Right, 4.4. Between which two consecutive terms of the quadratic pattern will the first difference be 453? Well, if we go back to our first difference line, is this one here. It's the negative 51, the negative 45, and the negative 39. And we know that is a linear pattern. So we can use Tn equals a plus n minus 1 d. This is the general term for a linear pattern. So we equate the 453 equals, a will be the first value of that linear pattern for first differences, that's negative 51, plus n minus 1 times d, and our d is 6 there. Remember, our d will be 6 there, which is this one here. So times 6. So you simplify, 453 equals, if you multiply that 6 in, you'll get a 6n minus 6. So negative 51 minus the 6 is negative 57 plus the 6n. Take that 57 to the other side, you get 510 equals 6n. Divide both sides by 6n equals 85. So it lies between the 85th and this 86th term. So between T85 and T86. You're going to get a mark there for getting 453 equals negative 57 plus the 6n, this one here. You get a mark there for stating n equals 85, and you get a mark there for stating it lies between the 85th term and the 86th term. And then 4.5, show that all the terms of a quadratic are positive, 4 marks. Well, we know Tn equals 3n squared minus 610 plus 300. If we complete the square there and we leave it in this turning point form, then we have 3 bracket n minus 10 squared plus 1. Now remember, whatever value you put in here for n, and you'll square that bracket, it will become a positive in any case. So n minus 10 squared is greater than or equal to 0, for n is a member of the naturals. And then even if you put a 3 in front, it will still be greater than or equal to 0. And even if you add a 1, well, if you add a 1, if you put in the 10 in there, you'll have a 0 here, and then plus the 1, that is then greater than 0. So it will be positive. All terms in the pattern are positive. So you get a mark there for leaving it in that turning point form when you've completed the square. 2 marks there, and you get 2 marks then for your argument here. Right. So that's the end of our second session for number patterns. Thank you very much.